Chapter 15, Earthwork Operations. Solid foundation must be prepared to support the roadways, buildings, and other temporary permanent structures to accomplish the task. Naval construction must perform an earthwork operation referred to as horizontal construction. Earthwork operations include much more than just moving earth. As an equipment operator, you must be able to detect things required to achieve the finished product, accomplish the pilot plan, the developing stage to complete the drawing, studying, understanding project drawings, compute earthwork volumes, reading, then using instruction, grade stakes, transferring elevations, leveling equipment, understanding characteristics of the soil, procedure for the earthwork operation. Project planning, naval construction with entire history, each of the construction project in initial phase through the execution phase, close out and documented the standard 9 folder. Project figure 15.1 is formatted used on task and for projects. 9 construction. A flowchart is shown in sequence planning. The steps of figure 15.2 with the steps are listed for the project planning milestone. Figure 15.3 listed for the normally assigned with the operational document at the beginning with the home operation. Step information on how the project is to be developed and outlined with the Navy Mobile Construction Battalion Recruiter Leaders Handbook or Third Navy Construction Battalion Instruction 5202X. Project drawings. In the Navy Construction project drawings are normally divided in the following major categories: civil, architectural, structural, mechanical, electrical, regardless of category. Projects serve everything the following functions. They're provided with the basic estimated material, labor, the equipment provided before construction. They're provided with the best provides instruction and construction, showing the site, the location, various parts. Provide means for the coordination between the different ratings. Completement of the specification. One source the information is complete with the other. Pages. Most drawings include sheet pages for the designated I, index C, civil, A, architectural, S, structural, M, mechanical, P, plumbing, E, electrical, W, waterfront. For example, the showing of the figure 15.4, the designated letter page number the 22D, architectural name and step of the plan, so the written A22 with the name of the title of the project and the largest block of the page for the equipment operator. Or to assign P&E teams, obtain the reviewed plan sections, identify special training block, and schedule a track, and identify long-term ideals and track unit deployment. Develop, obtain master activities, level 2, generate construction activities, make, take it off, and bounce off MTO and V versus BM, man day during estimations, precedent diagrams, resourcing level 2. Level 3 goes to reviewing by QC, safety plan, safety chew, review QC. MASG level 2 QC planning and review by QC, review company, and review by OSP. Project man milestones. Work should be concentrated in index, civil index. The index tells you whether the project is located within sight of the drawing. Special surveys have been done. Civil pages have been encompassed for the variety of plans. Information include the following: site preparation, site development, fencing, rigid flexibility with the roadways and walkways, environmental pollution control, water supply units. Depending on the site of the construction of the project, number of the sheet, the civil drawing of the page of the barium, the number of the sheet of the page of related drawings. Normally, on the average size project, the first page should have the location map, soil boring, log legends. Sometimes site with the plan says small civil detail drawings, small boring sites. Determine the water table over the construction site. Classify the existing soil. Site plan furnishes the essential deed layout of the proposing buildings is shown. Figure 15.5 shows example of site plan existing utilities. Figures 15.6 shows the plan profile, plan and profile. Figure 15.7 shows typical cross section. Counter boundaries, roads, and utilities, trees, and structures reference other significant physical features near construction site plan profile sheet with the figure 15.6 with a typical cross section, 15.7 with the other information on site plan. Symbols you with the drawing, contour lines you with the imaginary lines representing the course elevation, earth strip, the blueprints plans you with the contour lines show final proposed elevation. Existing contour lines identify existing elevations, existing proposed elevations, or use the figure cut fill operation. Proposed contour lines use those we work toward. Use the visual finished product. Utility line symbols and identifying utility symbols by the pipe shown figure 15.9. Utility symbols show the liter soil waste above grade, below grade, vent, cold weather, hot weather, return, drinking water, return of acid waste, compressed air, fire line, gas line, tailpipe, vacuum. Alright, figure 15.8 shows existing proposed contour lines existing and proposed contour lines. Existing underground facilities identify that you exist extremely working near them, rip up the utility lines, add the types until loss of time and project adds the cost of the project, cause the inconvenience to people who use utilities were supporting. Obtain digging permit before performing any excavation on the project. Supply electrical power distribution is shown figure 1510. Note that the location of these lines not only recently stated about the pipe, but also cover the restricted electrical shop, machine cuts, and electrical line. No, only some occasions certain items mistakenly left out on the new drawings. Example: the building, telephone lines, electrical wire, water lines, fuel lines. Because of these lines make it practical compared to older drawings and new drawings with this freehand sketch. Symbols of the building materials are shown in figure 1511. Symbols of the cross section cut away. These are labeled as materials. New existing sketches. Freehand sketches are made with the drawing made with the mechanical aid devices. Sketch made the drawing, graph paper tracing shown the drawing. The straight edge should be sketch may be an object and an idea. Combination of both ability may be quick and accurate. Sketches helpful and convey your idea to others. To example of freehand sketches shown in figure 1520, 1512, and 1513. These sketches were 1511 showed the material soils, gravel, earthwork, stone, concrete, rock, and asphalt. Alright, 1510 shows electrical power distribution. 2 conductors, surface above the ground, secondary street light, underground buried cable duct line, 3 or more conductors no more than crossing lines, no more than the number of conductors. Incoming lines can duty with the group conductors. Branch of group and conductors notice of the number of the embracing the grounding. 12 show the overlay plans with emphasizing cuts and fills. And 13 show the overlays and provides temporary road and curve. Develop the original plan profile sheet with a typical road project. Depict the earthwork phase. Consider the equipment and operator engaged in movement operation. Sketches shown in figure 1512 and 1513 are played with a piece of the tracing paper directly over the plan profile sheet. Tracing the new roads and stations. Information was added not include the original plan profile sheet. Should be borrowed the pit, waste, pit stream, temporary haul road, temporary culverts, equipment area plan, and cut fills there. Typical road sections. Any information may be included in this all individual furnished product. Earthwork computation or calculation. Earth volumes quantity determined to follow the grade balance and cut and fill of the plan. The most economical value movement is material volume changes the most of the earthwork computed with the cubic yards. However, the sum of the project drawings and metric set used in the cubic yard is in 3 feet, with a 3 feet wide, 3 feet high, many dimensions filled with the measurement contract plans and so they are multiplied together where they obtain the object length and width times the depth. The result of the cubic feet to obtain with the cubic yard with the cubic feet divided with the cubic feet by 27, the cubic 27 cubic feet and 1 cubic yard. Also possible to divide with the original linear measurement of the 3 convert by 3 to convert the number into yards when the multiplying. However, the may leave the working the fraction decimals mixed numbers. Cubic yards material either been placed loose and compact material excavated its natural state with increase of the volume commonly known as swell. Undistributed material is in place cubic yards and material loosened with the handle to measure with the loose cubic yards. The volume compacted with the material measured with the cubic compact cubic yards. Note when the calculating estimate for the project drawings you may estimate the cut as in cubic place cubic yards and estimate fill as compacted cubic yards. Calculate the correct amount of material of the handheld to show that you convert present soil conditions using 15.1. Road nomenclature. The cross-section view of the road is in component shown figure 15.14 before any construction is on the project site. Elevation known as existing grade. Figure 15.14 show that the road nomenclature: ditch, four slope roadway, roadbed, travel way, crown, shoulder, existing grade, V ditch, surface, subsurface, surface course, base course, subgrade, flat bottom ditch, a ditch back slope. Surfacing existing road with the replay with it known as the existing grade, subgrade of the road with the prepare with the base of the place of the base course with the material, the base course selector of the well compacted soil with the place with the compacted lifted top soil with the subgrade compaction can be accomplished. Mechanical stabilization, chemical stabilization, saves the scores, shoulders complete the road surfaces usually. Concrete asphalt part of the road with the vehicles untraveled and shoulder road or performs the retainer at each side of the subsurface course provides emergency parking area. The crown is on the roadway, establishing the slope of the center line of the roadbed. Outstanding with the shoulders allow the excess of the water to drain the surface in the V-type of the flat bottom type of the ditch for the area that covers the entire width of the road. Alright, figure 15 show the volume changes 1.25 cubic yards after digging loose. Cubic earth 1.1 cubic yard natural condition in place yards and 0.9 cubic yards after compaction compacted yards. Soil of sand types common earth, clay, rock, and presented soil in impact, loose, compact, in play converted to impact, loose, or compacted. Project including the ditches is shown with the roadway. The roadbed is shown with the include the safe surface of the bowl shoulder, the travel way, and surface of the curve of the vehicle travel. Slope ratio: the most common slope of the U of the construction, four slope and the back slope. Four slope extend with the outside of the shoulder, the bottom of the ditch, the backhand extends to the top of the cutting existing grade, the bottom of the ditch, among the slopes in the four slope of the back slope of the ditch. The ratio horizontal distance, vertical distance 15-15. That means that every one of the foot vertical up and down or horizontal distance change proportional to the following are equals to compute the slope rate. Show that if the base is height with the known factors, not the slope, use the following. Base plan divided by height equals slope. If the slope ratio of the height are not known, but the base is using the slope times the height equals the base. If the base and the slope ratio are known factors, but not the height, use the base divided by the slope equals the height. Alright, show the slope ratio, 3 to 1 slope, the 3 foot horizontal distance every 1 foot with the rise, and then the ratios that we just read. Your cross-sectional view of figure 15-16, the road projection cutaway end of the proposed station with the left side with the right side with the retraction. Typical cross-section applied with an intermediate place for the distance chain, the sloping area of the center line with the natural grade profile. The grade line corresponding with the cross-section display the slope show slope limit, slope ratio, horizontal distance between center lines taken, shoulder distance. Also show the vertical distance proposed with the cut and fill with the shoulder center line. To compute the area of the cross-section, you must first break it down into geometrical figures, square triangles. Sketch your figure 15-17, compute the area each of its square separately, then total result to depend the total square feet. Figure 5-16 show the cross-section 10 foot shoulders from the center to center, 2 by 2 by 3 by 1 for 8 foot and 15 slot. 2 compute area of the cross section. First break it down into geometrical figures, square triangles, etc. Then compute each separate and total then the results. Area A, area B, and area C. Compute the square area with the square of the rectangle figure 15-18 with the following equation. Area equals the base times height, or area equals base times height. Such a rectangle and square of the rectangle, half of the diagonal, same question. That's computed with the area with the result of divided in figure 2. If you have 19, for example, the triangle area of the square foot is equal to base times height divided by 2, base times the height divided by 2, triangle area in square feet. And another geometrical figure encounter with the cross-section of the trapezoid, figure 520. The equations compute the area of the trapezoid as follows. The trapezoid is square feet is h height plus height 1 plus height 2 divided by 2 times length. Height 1 side height 2 plus the height of the other side, sum of the 2 times the length. Trapezoid is square feet. The next step of the compute the total area of the cross-section, figure 20-21. Accomplish additional resulting geometrical in the crosses. Squares and rectangles may be computed either areas of using the area and the base time height. The explode of the height squared on the base height, rectangular height 3 base times height, and for computing area of the triangle as follows: area equals base times height divided by 2. The section of the values total and with the cross-section will be the compute the amount of cubic yards in the two cross-section using the following equation. Area 1 times area plus area 2 divided by 1.85 the the distance cubic yard, the area 1 of the cross-section, area 2 the other end of the cross-section. 1.8 constant factor distance between the two areas must be changed to decimal form from 250 to 2.5 or 125 feet, 1.25 or 75 feet, 0.7 so forth. Compute this equation and take the cross of the area 1 end cross-section plus the other end with the multiply the sum of the two areas constant. Factor 1.85. The value should be multiplied the distance between the two ends of the areas to determine the number of the cubic yards. See figure 55121. Our construction grade stakes grade with the plotting irregularity of the ground marking custom fill the definite limit of the grade elevation alignment of the perform of the reading information placed on the construction grade stake. Following form including the trapezoid as follows: the area equals height times 1 height 1 plus height 2 divided by 2 times length. For computing cubic yards as follows: area 1 area 2 plus 1.85 distance cubic yards. Construction safe, sometimes referred to as grade stakes guide with a reference mark for the earthwork operation, show cuts and fill drains align with the boundaries of the construction area with the number of the stakes with the information contained with the name of the area in project for this. 12 they are temporary permanent stakes are usually placed in 3 to 5 person survey party using level the rod and tape them for range pole. The stake is defined as the wooden layer stake with the hub stakes are 2 inches by 2 inches, approximately 12 inches used primarily for the well-defined surveys. The reference point with the red blue finished grade work of the stakes will be very shape of the size according to their use of the materials available to their manufacturers. Several stakes are shown. Figure 1522. Stakes range design ordinary rough plaster, the lap with a 1 by 1 to 3 inch cross-sectional lumber with lengths varying from 18 to 48 inches. All reference hub markers the benchmark for the establishment engineering aids for the project with the course control alignment project with the guard stake. With the guard stake should be the means of locating with the points needs for the sum of the blending with the flanching and the narrow strip of the cloth or plastic be tied around the top of the stake with the station identification plate in the front of the stake with the other permanent data with the back. In some situations, the survey crew will establish grade stakes on the center line with the edge of the road with a slope stake with a set with a projected supervisor to help with the alignment. Show the slope of the stake should be 1 by 2 inches, then cross section smooth on 4 sides within about 2 feet in length. The actual grade indicated with the reference mark with the crow, called the crow foot, and number to show in the amount of the cut and fill. Figure 522 shows the stakes, the flanging stakes, and the lath and the hub. These stakes should be marked in the following information: station location, any part of the road, runway, tax, relative to the starting position reference, the amount of the cut and fill from the existing ground surface, the reference of the mark on the stake, the distance center line with the stake location with the center line, the ditch, and most of the earthwork with the measurement of the made with the winner of the decimation, the instruction of the engine marking with the construction stakes, B feet and tenths of the foot, the start to make mark C3. C3, making the cut made at 3.5 to convert the 5.5 foot inches, multiply the decimal fraction by 12, for example, the 5 by 12 inches, 6 inches, or a quarter by 12 inches, 3 inches. The starting point survey is also called with the starting station number to 0 plus 0. The next to the station is 100 feet farther away, the number to 0.00. The next station is 200 feet behind the starting point, number 200. Further, all the station end with the call of the full station shown. The stations may be abbreviated as ST or on stakes. The sharpest curve on the rough ground stakes may be close together. Then straightaway stations located the distance within 100 feet from the preceding station known as plus stations. Starting plate states. The starting plate 00, 100, and then starting plate 20. 3 times plus 25, 3 plus 53, 3 plus 77, for example, the plus station, 3 plus 00. Line stake on alignment, this must be horizontal location. Earthwork must be completed to give the direction of proposed construction run over the stakes, otherwise damaging the stakes before it has served the proposed result with the main hour of the exterior work replaced with the delay of the completion of the project. Rough alignment stakes replaced with all head of the crew, clearing crew to mark the lounge, with them clear of the grub of the round stake. The marks on that are not the control nature for these laws expected on some stakes. Alignment with the information grade requirement are combined in the same stake. Figure 524. 525 shows the combined alignment grade stake. Center line stakes are along with the center line of the project. There with the center line stakes are identified with letters and shown figure 525. Most stakes are marked on the front of the back. On the center line stake, the station number is written on the front of the stake. The 0.001, 1004, 175 is 525, figure 526. 525 shows the center line stake. The required to be established in the center line project, the amount of the chain of the elevation written on the back of the center stake, the cut and fill, which is known as the crow foot. With the crow foot is referenced in the vertical measure of the grade. Figure 526 shows the station, road lane stations, stakes and set curves on the and hills. Figure 526, the cut and fill crow foot for cut and fill crow foot symbol. Alright, shoulder stakes that are set when the line parallel the same in the direction interval of the center line are called shoulder stakes. They're identified the same as the SH top of the stake. The shoulder stakes are marked with the outer edge of the shoulder set with the broad side of the facing. Center line with the road shoulder line with the shoulder stakes gave the same station number of the center line set with the bottom of the station number of the plate for the back of the stake side facing with away from the center line. The amount of the cut of the fill is marked on the side of the shoulder stake facing the center line. Front with representing the amount of the cut and fill required at the location of horizontal distance from the shoulder stake to the center line. Some tiles beneath their cut or fill figure of the base rim to determine the center line marked with the center line symbol to show the stake. Shoulder stake, then show the center line shake and set along with the center line with the project shoulder stake, the parallel with the center line defining the shoulder of the road running runway of the center line, figure 529. 529 shows the center line shoulder stakes. Cut and fill stakes lowering the elevation grade is zone with the money making cut stakes are designated with the letter C on the stake. The numbers are following the letter C, but they indicate the amount of the grade to be cut and obtained with the desired grade with the measure with the crow foot down. Raising the elevation of the ground number with the filling of the fill stake is designated with the letter F on the well, written on the stake with the number of the file with the fill, indicated the amount of the ground need material need to bring the exact ground to the desired grade. The error measured with the crow foot make up the stake plan and making of the cutting of the fill and the vice versa. There's many of the more stakes representing the points on the cut and fill on the grade stakes, crow foot, and the filler stake and the ground stake. Show the grade stake. Design grade is shown in figure 533. Stake with the mark for the grade of grade with the crow foot, make it even the desired grade. Basically, the difference in cut and fill on the grade stakes is cut stakes indicate lowering of the ground and elevation, and fill stakes indicate raising of the ground elevation. On the grade stake indicates ground as it is to desired ground, and it does not need to be cut or fill. Offset after a survey of the project has been completed, the stakes are set and marked the required amount. Work needed to complete the job determined to use the information with the stake. The information has been used to determine the construction of original stakes can be destroyed and covered with the careless, inexperienced operatives necessary to document this information. To prevent the loss of reference information, you should transfer the required information to the stake located immediately area of the construction. New stake of the stake is far enough away for the will not damage the destroyed equipment being operated with the construction area. The new stake is also called the offset stake, identified by the symbol OF or O, figure 531. You should note the number of the linear feet with a separate offset stake of the original reference stake with written in the offset below the offset within the circle of follow the amount of cut and fill in the feet, which may be required. The stake mark with the off stake 31 feet, CL with a C on the 1 foot, means the stake is 31 feet from the center line. It won't be 1 cut foot required to attain the design final grade. The difference elevation must be noted in the offset stake. The symbol representing the stake of the information was originally transferred. There's note of the offset stake. The offset stake was offset with the shoulder stake. The symbol would be shoulder and then from the ground level. The amount of the cut fill measured the offset stake, however, because of the existing information, offset stake may be not as same as the original stake. Figure 532. You may see the offset stake is a cut made to reach in the desired elevation center line. While 531 shows the reference information found in the offset. The offset stake designated reference shoulder offset with the shoulder stake. The difference the reference make the difference of elevation indicates cut fills and reference marks measured in this stake crow flat. Alright, the offset stake, ground level, the center of the crow foot, and 40 foot on the desired elevation center of the level of the 2 foot at the crow foot. Center line stakes should be marked with the fill of each reach of the same elevation. Slope stakes, identifying marking the slope stakes may vary according to survey parties. However, the symbol of this SS most commonly used for the slope stakes. The information normally found in the slope stake is any of the cut fills requiring the distance from the center line slope ratio when necessary to offset the slope stake. The offset distance for the slope stake should be written at the bottom of the offset slope stake and indicate the intersecting the cut-off slope with the existing natural ground line limiting earth on each side of the center line. Right-of-way stakes. Stakes are in property line with the construction known as the right-of-way stake. These stakes mark the boundary side of the project must be not operated with equipment offside over the property line defined with the right-of-way stake. The right-of-way stakes are usually marked on the color-coded blunting, flagging. Occasionally, right-of-way stakes are marked with the symbol of right-of-way. Figure 534. Our finishing grade stakes. When performing final grading, you are likely to work with 6 stakes. Blue top of the hub of the stake, they're usually 2 inches by 2 inches, 6 inches. These hub stakes are driven in the ground until the top is exactly elevation of the finished grade to determine the surveying crew. They control with the blue lumber crayon keel to identify these finished grade stakes. Red crayon is normally used to indicate the subgrade elevation. Blue stakes are placed in the existing grade when it is 0.2 feet or inches or 2.4 inches above the final desired grade. The desired grade is obtained lowering, raising the compact grade until flush and even with the top of the hub. Figure 536. 533 shows the slope stake, and then 535 shows the right-of-way stake. Slope stake, natural ground level. The slope stake, existing natural ground level. Alright, leveling equipment. To see that you compute the graduate stake measurement, they must be able to measure the vertical distance with the one point to another. The process of leveling is accomplished by using leveling equipment. Level the instrument that you the measurement of the vertical distance, level the light level, line of sight, the measurement mobile device, maintain the instrument in the horizontal plane, level the varying in these accuracy. According to the quality manufacturing power of the length and vertical distance required, measured for the sighting of the ground graduated route called the lever route. The other surveying equipment used the measuring distance level the route usually graduated in feet, tenths, or hundredths. Hand level the generally round metal tube that used extensions along with the eyepiece on one end with the crosshair on the other level the valve on the top. The figure 537 part of the crosshair when they covered with the mirror with the reflect with the image of the bubble to the viewer. The UV the hand level to locate the eyepiece with the end of the rod live visible on the top. Tilt the hand level until the bubble to the center with the crosshair with the while looking through the eyepiece, and sometimes necessary to hold the height of the level above the ground where you are standing. This may be accomplished for the resting level on the stick known. 536 shows the finishing grade, compacted grade. 517 shows the hand level. This line is usually the crosshair, the bubble, the reflection of the mirror, the 1/2 mirror, the front plane glass, and the same hand level across with extend with the width of the telescope. Alright, Jacob staff, height of the level using Jacob staff at the hand level. The dummy level shows the eyepiece and the retacticals, adjusting screw, focusing screw, level, veil, shade level bar, azimuth clamp, leveling screw, azimuth tangent screw. Length. The stick known as Jacob's Dash is shown in figure 38 for the rough work. May ignore the stick with the premier leave the height for your eye to above the ground normal standing position. Hand level is checking the grade during the rough, the early part of the construction project. Normally, use the distance greater than 50 feet, even lesser distance and accuracy to more than 2 or 3 tenths if it's required. Dumpy level. Dumpy level figure 539 has a telescopic bridge attached to the level of the bar which supports the adjustment high sensitive level of the valve. The crosshairs are brought to the focus rotation IP for the focusing. Now the telescope can exactly train the level of the rod, lightning azimuthal clamp, manipulating azimuthal transhift depending on the atmospheric condition. The dumping level that can be made with the vertical distance accurately distance 300 feet or less when you use the fore alignment, the accurate distance up to 4,000 feet. Self-leveling level. The self-leveling level 1540 with a precise time saving level instrument is equipped with a small bullseye level 3 leveling screws and leveling screw which are in the triangle foot with the area center of the bubble. The bullseye level line sight automatically becomes horizontal, remains horizontal as long as the bubble remains approximately centered and prismatic. Figure 554 shows the self-leveling eyepiece focusing knob, circular bullseye on bullseye, bubble on bullseye, and leveling screws. Our device called the compensator makes it possible the compensator suspend with a line magnet where the activity of the gravity compensator for the optical length swing with a position defined to the horizontal line of sight. The horizontal line of sight maintains despite the outlet on the telescope even the slight distance. Your tripod figure 542 for the base of the foundation support level instrument. To keep it stable during the operation, tripod consists of the head of which the instrument is attached to three wooden or metal legs hinged for the head of the point of the metal shoe for each of the head leg is pressed and anchored into the ground and achieve the firm setup. Setting up the tripod, loosening the restraint with the strap around to three legs. Effective way of the setting with the tripod and gripping the two legs and closing your body weight and do it while you're standing over the point. While using setup of the tripod, using one hand, push the third leg out of the way of your body until it's about 50 degrees, 60 degrees horizontal. Lower the tripod until the third leg is on the ground. Place one hand on the first two legs, spread them while taking a short backward step, using the third level as a pivot point. Then the two legs, and then with the farthest way of the mark is the third one, all the way three equal. Space lower two legs, press them equally. Figure 542 shows the tripod. Figure 541 shows the self-leveling compensator level line outside compensator telescopic horizontal cross line. When telescopic tilts, compensator swings backwards. When telescopic tilts downward, compensator swings forward. Ground, make any slight adjustments level over the head, further moving the third leg with a few inches in or out. Move before pressing it into the ground. When placing an instrument on the tripod, grip the instrument firmly to avoid dropping while the air mounting on the tripod. The instrument should be screwed down with a firm bearing, pronounced slightly, that binds the screw thread strip. Heart level rod. The most often used level rod of the Philadelphia rod shown 1543 with a graduated wooden rod made of two sections can be extended to 7 to 13 feet. Each section subdivided in hundredths of the foot, each in hundredths of the foot being marked with the line and take the distance between the alternate hundredths of the painted black on the white background. The distance between the color and the top of the black is the even value of the black. Black is the odd value to the tenth of the marks numbered in black and the feet in red. Philadelphia level rod with target figure 1543. Direct readings are taken off the self-reading held plumb point with the rod man with working the 10th of foot. Relatively simple to read. The foot mark with the cross of the hair with the 10th mark with the cliff of the crosshair. But working with the hundredths of the foot is more complicated with examples. Suppose you're making the direct reading with a component of 5.76 on the Philadelphia rod graduation, or 0.1 hundredth of a foot wide and a hundredth of a foot apart. The reading of 5.76 feet. There are three black graduation 5.70 foot mark and the 5.765 foot mark shown in 1544. Since there are three graduation, the rod may be misread 573 feet instead of 576. The 5 foot mark for the 6 foot mark does not show in figure 554 with the split in the sight through the level instrument. You must not be able to see the foot. Show the 576 mark, 570 for mark, and you can't see the foot. When you can see the next and low foot mark through the level instrument, you signal ask the rodman to raise for the red. The rod from the slowly to raise the rod for the next level. The red number comes into the view. Note the feet measurement in the Philadelphia rod are in red. Target reading. Conditions on hinder direct reading of such as poor sight, visibility, low sight, and partial obstructed sight, thorough brush leaves, and sometimes make it necessary to use the target. The target is also used to mark the rod reading of the numerous points at the same time. To set the same elevation instrument setup. Alright, target 1545 with the Philadelphia rod achieves the oval, the long axis for the right angle of the rod with the quadrants of the target painted alternately red and white. The target is held by the C-clamp with the thumb screw left with one face over the target. Receives the fine adjustment of the target line with the sight level. Targets having the rectangular openings approximately width of the rod and 0.15 feet high, through which the face of the rod head may be seen with a linear vernier scale is mounted on the edge of the opening of the zero. The horizontal line of the target reading thousandths of a foot. The target issued the rodman takes the rod reading. When sighting through the level, instructing the level man either up and down so the rodman can play for the horizontal separation target in line with the horizontal cross of the hair instrument. With horizontal separation, a horizontal crosshair coincide with the level man weighs all right. All level man signals are alright with the rodman target tightens of the target clamp the rodman hold of the rod until the point of given the trip of the target has slipped wave. The rods push into the bow, foot away from the towards the body to see if the rod was intentionally held in an absolute vertical position. The level men should recheck the target reading if the horizontal crosshairs do not coincide. The target must show the target or diagonal lines indicating the target of 4,000. Note the vernier graduation zeros index. Zero elevation. Datum point, also called the 0 point elevation. Elevation shoreline. Be reset to the rodman reef the target in the 10th of feet with the 100th of the nearest foot. Graduation below the horizontal quadrant separate in the line of the target equal operator and seldom burner scale earthwork operation. Leveling the vertical distance measured during and level the difference of elevation between the 2 points. The term elevation refers to the height of the point in a particular spot with above the below the reference line called the datum and the datum plane. Datum is the two general types of actual and assume the actual datum is mean scene level. The figure 1546. Assume the datum is the imaginary level. Assumed elevation 0 is inconvenience. The leveling procedure reference point of the elevation is known as marked as the benchmark. Either a starting point leveling as point with the closure and checking the accuracy of the work. Your benchmarks are classified as temporary and permanent. Temporary benchmarks are established by either TBMs or either the particular job and maintain the duration of the job throughout the United States. Here, the benchmark mark has been established by various governmental agencies. The identification markers are in stone, iron pipe, concrete, and then sometimes marked within the elevation above the sea. Typical marks are shown in figure 1547. Federal benchmarks. You have your geological surveys. Substantial object may be with either the benchmark in figure 1548 view A show of the typical monument to set the mark alignment with the point with which must be the benchmarks. The spikes may be driven into the points power poles as shown in figure 1548 view B. Chiseling the stone concrete structure shown in figure 1548 view C with the clarify the marks as shown with the wing wall. But in the practice, one mark is usually chiseled or spray painted on a flat surface. Location, elevation, description of the benchmarks usually shown on the project drawing, survey field notes. Determination elevation when benchmarks establish certain formulas to determine elevation. As you can figure the height of the instrument is done to take the reading of the level of the rod on the plate. If known the elevation such as the benchmark, this is done on the backside. Determine the height with the instrument with the benchmark of the elevation on the backside with reading the level of the rod. The formula is equal to the height equal to the benchmark plus the bench site. Backside. For example, the figure 1549, the benchmark at elevation is 100 feet, the backside reading. Ratio of the brass shaft block, 1 1/4 inch brass shaft block, brass shaft, 1 1/4 inch concrete, and iron pipe, and face view, BM, benchmark, elevations, spike side, face view, and side view, benchmark, blaze patch, spike, and D, chiseled mark on concrete. 0.5 feet benchmark elevation out of the backside reading they gave the instrument with 105 feet heat. Notice since the backside reading is adding the elevation benchmark to the obtain the instrument height, it's usually called the plus site. Once the height is instrument established, you can determine the elevation at any point with the instrument range. Determine the elevation of the point after the height has been established. Place the level of the rod on the point of the question. Take the reading through the level of the site. The glass called the foresight reading is subtracted with the height. Determine the elevation of the point. The formula is determined by as these height versus minus the foresight is equal to the elevation. For example, shown 50 height of the instrument of 105 feet, foresight reading 2.3, instrument height minus foresight reading gives the point elevation 103.2 feet. Alright, backside reading determine instrumental height, bane sea level, benchmark and backside 105 feet height, benchmark 5 feet, 100 feet. Height versus foresight elevation benchmark foresight elevation. Or checking grade level instruments. The check example: the checking the ground spot with the desired grade level instrument shown figure 15.1, 1551. The hub stake with the side of the construction represented the alpha stake. Grade stake with 1551. View A. Grade stake call for the cut of the 7.5 feet. You must step below level 2 reading the first of the hub, then on the excavation. Your first reading is 5 foot since your excavation is supposed to 7.5 feet below the hub. Your second reading should be 12.5. 5 plus 7.5 as shown. Must the both at the bottom above the rod reads 12.2. Therefore, you must cut 0.3 feet more to finish the subgrade. In Figure 1551, View B, first reading the 12 feet of the hub since the stake called the F on the 7.0 should read 5 feet completed fill. The fill of the 7 foot should read the 5 and completed fill month rods of the 5.5. Therefore, you must another half foot to finish the subgrade. A missing grade stake. A missing grade. Another leveling procedure is to compute a cutting fill requirement measuring missing grade stake. The figure 1552 fishing elevating project drawing points. Point B supposed the 378.75 feet set up to the level of the backside shot of the benchmark at the point A. To give the direct reading of 11.56 feet. 11.56 backseat reading plus the benchmark elevation of 306 foot 0.1 feet. Give the ignorant instrument height of 376.65 feet, 376.57 feet. Then take the foresight shot at point B, give the direct reading of 1.42 feet. You now subtract the foresight reading of the 1.42 feet for the instrument of 376.57 feet. Find the existing ground elevation 307.15 feet. You now take the required finishing elevation 378.8.75 feet, subtract the existing elevation instead of 3.75 feet, give the fill requirement 3.6 feet at the bottom, and the fixed excavation elevation greater than required finish elevation you must be required to cut. Another example of missing grade stake is shown in Figure 1553. Suppose the stake is a station 4 with a 50 plus 15 that knocked up, then there's no more benchmark. Issue of the ground simplified stake, the hub stake, the center stake, checking cut, and then checking fill stake. Computing fill requirements missing grade stake, finished grade, existing ground, replacing missing grade stake. Alright, nearby, but you'd have nearly grade stake of the station 4000 project drawing. The 400 project drawings call for the subgrade elevation of 240 feet. The stake station of the 4 fill of the 7 feet. The existing elevation of 303.007 feet below the 240. Set up a level grade, take the backside reading of this 004 feet, the backside reading of the 4 feet, plus the existing known elevation 233 feet. Again, gives the instrument height at 237. Then you take the foresight station 450, give the direct reading of the 4.5 feet, subtract the foresight reading of the 4.5 instrument height with 237 feet. You get the station 4 plus 50 for the existing level of 232.5 feet. The project drawing show the finished subject grade elevation 4 at 50 for the 239 for the existing feet at 232.5. You must fill as the station 450 total 6.5. The read of 239 feet required subgrade elevation. Therefore, you should place the grade stake at station 450 as marked as fill 6.5 turning point. Alright, turning point. 2 missing grade stakes. Example that will be based on elevation nearby points. Could be read with one of the setup of level. The difference elevation distance are too great with air obstructions. Will have to make the immediate setup of the site point called the turning point. With any convenient point, maybe you the turning point. The level of the rod must be set for the ground. Some of the firm object is over the elevation of the turning point will not change with the rodman waits for the level man to set up a new position. Example of level running is shown in Figure 1554 with the benchmark with the bottom of the bank. There you will find the elevation of the top bank, which is point A. You can set up the top of the bank to take a reading of the level of the ground and hold the point A. Because to take the back shot of the benchmark level of the rod is too short. First record the benchmark elevation at 120 feet and next to the setup the level instrument the bank rate. Bank and take the back sight shot of the benchmark to get the level of the rod reading of 10.2 feet, adding the back sight shot to 10.2 feet, the benchmark elevation 120 feet. To give the instrument height of 132.2 feet. Foresight shot of the turning point to give the level reading of 1.2 feet. Subtract the 1.2 feet foresight reading from 132.2 feet. The instrument height to the turning point elevation is 129 feet. Next, move the instrument on the top of the bank. Take the back side of the shot with the turning point to level the rod, reading the 9.8 feet. Add the 9.8 feet back sight, reading the 129 feet turning point elevation. Give the second instrument height 138.8 feet. Last step, then take the foresight shot point A on the get a level rod, reading 30.8. Subtract the 3.8 foresight reading from 138.8 feet. Second instrument height going to 135 feet point elevation. A. Some level runs may require more than turning point. However, no matter how extensive the job, the procedure always is the same. You add and subtract successive rods, reading from the point known in the elevation to the point of the unknown elevation. Measuring horizontal distance. The setting of the replacing grades resistance grade 6, measuring horizontal distance with either woven tape or steel tape. Turning point level notes. A woven tape figure 1555 is made with a high-grade cloth with a used fabric of the metallic woven tape that reinforces them from the fine bronze with bronze wire mesh. With the non-metallic woven tape does not contain the mesh. However, some of the non-metallic woven tapes are coated with plastic. Woven tapes are made in 25, 50, 75, and 100 foot and 50 foot length. Some of the graduate with a feet and inch of the nearest quarter inch point. Others graduate in feet and decimals of the foot, nearest to the 5 hundredths of the foot. On most of the decimal grade woven tapes, only a tenth of a foot graduation marked in numerals. Steel tapes are used to measure with requiring great precision. The possible woven tape, the most commonly used steel tape, is 150 feet. The graduated feet and tenths of the hundreds. Some steel tapes are graduated throughout. On others, only with the first foot graduated subdivision body with the tape that graduated on every foot mark. A steel sometimes equipped with a reel with a tape that can be wound. The tape can be detached from the reel for the more convenient use in taping. Convenience of the carrying one place to another, the detached tape can be made into a coil, commonly called as a doing up of the tape. This is done by placing a 100-foot end or a 200-foot or 300-foot end, etc. in the left hand, facing up the rear reach of the bench. Back of the right hand with the grasp of the 90-foot mark and bring it up and place the face up to the 100-foot mark. Do the same with a 90-foot bench mark, an 80-foot 5 mark, and 70-foot mark, and so forth until you have gathered the entire tape. And you will find the tape now forms a figure 8 and is shown in figure 1556. The figure 8 can be formed in a circular coil as shown in figure 1557. Our figure 1555 shows the woven tape, and then 1556 shows doing up a steel tape and steps in throwing a steel tape into a coil. 1, 2, and 3. Alright, errors and mistakes. Some of them common errors and mistakes made with leveling are as follows. Inaccurate adjustment instrument. The most commonly instrument error is called the leveling out adjustment. The instrument must be adjusted so the line horizontal when the bubble is in the center of the tube. Error sighting the eyepiece for the telescope thing properly focus the road. Rearing appear with the chain with the position of the eye chain with respect to the eyepiece. Errors due to the chain with the position of the instrument when the instrument is not properly leveled. The unstable error due to the settlement with the result of the unstable instrument set up and makes the level of the bubble the treble and some of the everything enough that it appears to properly center with the check of the position of the bubble before each of the rod reading to make ensure the bubble has remained in the center of the tube. Faulty handling of the rod may be not properly plumb if the rod is not held in plumb and it leans toward the wave of the instrument. The result will be excessive reading is errors in the rod length. Check the length of the extending the leveling rod with a steel tape. Fair to clamp the rod in the proper place, extend the leveling rod. If the error could result in the reading of the working mark of the rod, reading of the working wrong crosshairs, inspecting the chain position before each of the sight is make sure extended rod has not been slipped down. Soil. The soil is an important part of solid foundation, poor foundation, eventually cause the roads and roadways, buildings, or other temporary permanent structures to collapse. Soil formation. Soils are formed with the breakdown of soil, rock mass, permanent material within the smaller particles, which have even some of the rocks have been crumbled up so that they are softer than the other ones. This one is the step of breaking down the rock into the soil. Rock wears away with its contact with the moving water is seen with the stream beds and river. The rocks also breaks away when the freeze and thaw, when rocks heat up in the sun, then cools and quickly and then crack. Soil profile. During formation, soils are a natural profile made of 3 distinct layers. The upper layer of the horizontal made mostly with the organic materials. Because the materials are spongy, drained properly, they do not compact. They are normally removed from the building. Any of this layer building anything on this layer. B, the horizontal line directly beneath the view of the A horizon. The layer is lightly in color, made of the sand, the gravel, silt, or clay with the seldom itself in the natural shape, made up of only sand, gravel, clay. Most soil is made up of the mixture of the four. However, the strong for redrainage soil depends on the type of the soil, amount of the inch of the mixture. B, horizontal usually makes up all types of pavement construction. C, horizontal rock is natural state. It is sometimes called the parent material. Because of this, is the B, horizontal material comes from, and very seldom is the project built on a sea horizon. Soil properties. With experience, you will learn you can use different properties. Soil advantage. Soil properties are as follows: expansion, contraction, plasticity, and cohesion. Expansion and contraction are undesirable. Consider for the solid foundation that must be monitored. Soil closely. Clays and some forms of silk expand, contract with change of the moisture contact. Plasticity is ability of soil to mold into shapes. Some clays and tilts are also plastic and can be a problem if not controlled properly. Cohesion is ability to apply to stick together with the dry. Good example of the clays, which are very cohesive. The plastic, more plastic as soil is when wet, and most cohesive it was when dry. Alright, soil classification. Soils are normally work in the earthwork operation classified as forest, coarse grain, fine grain, or organic. Coarse grain soils are classified and composed of the sand, gravel, and or horizontal cross grain soil with 50% less more, passing in the number 200. C, the grain shape of the variable round to the angular has been load-bearing qualities and grain freely. Fine grain soils. Fine grain soils are composed of silt and clay and are built in the B horizontal. 50% more material passing from the 200 sleeve. The fine grain soil has good load-bearing qualities. Dry. However, the soil is drained properly when wet. They have little and no load-bearing strength with the characteristic, especially with true with clay. Organic soils. Organic soil is sometimes referred to as topsoil. Commonly, mostly of the decayed plants and animal material are in the A horizontal section. Retained material difficult to compose, compact, and normally even in landscaping and finishing projects. Soil size are grouped to the side of their particle, the grain. One method to use the distinct size through the use of sleeves. The sieve is a screen attached across the cylindrical medical frame. The screen allows the material smaller than the opening of the valve within the retained large particles. Sieve screen opening different side allows you to start the soil particle groups and based on size. Sieves are designated with a screen opening size, for example, 3-inch sieve that has a screen opening with 3 inches. The number 4 sleeve has a 4 opening with a screen that has 16 openings per square inch. 1558 soil profile. A is the horizontal, B is the on top, middle, C is the horizontal. 3-inch, 2-inch, 1.5 inch, 1/4 inch. Number 4 gravel. Coarse grain gravel from ½ inch to 1/4 inch. Number 4, number 10, and number 20 gravel. Coarse sand is between number 4 and number 10, number 20, and number 40 oil. Fine sand is between number 40, 100, and number 200 sand, and from sand is from number 10 to number 200, number 20, number 1, and number 100 sand, and the pan is a fine grade soil. Alright, if the soil sample the path of the 3 inches of the seed, but it does not pass the number 4 sleeve with a large particle size within an inch of the smallest of the smaller larger than 1/16 of the inch, soil is classified as gravel. Soil that passes the number 4 sleeve that must be retained with the number 200 sleeve or classified sand. Turn for the broken down in the coarse sand, the fine sand, coarse sand passes the number 4 sleeve, then retained on the number 40 sleeve, the fine side. Fine sand is the number 40 sleeve, retained on the number 200 sleeve. Any soil passing the number 200 sleeve is classified as fine grade sand, fine grade. Soil graduation. Graduation described description distributed the different differential size of the soil. Same with the well-graded soil. Figure 56 soil sample with all sides of the material present with the number 4 sleeve with the number 200 sleeve. Poorly graded soil made with the uniform grade with a gap grade with the figure 56.1 and 56.2. If the soil of the ununiform grade most particular about with the same size with the example of the season analysis, which is size number 20, only size present. If the soil is gap grade with at least one particle size, the missing example of the gap grade soil is one of the sieves, and unless reveals the sand size number 10 and number 40 are missing. Others are present. Soil compensation, compaction, and pressing together some soil particles form a consolidated mass increase in particle stability. Figure 56 is a well-graded soil. Figure 56 with the uniform grade soil. Figure 562 shows the gap-graded soil. Compaction helps the soil with the moisture resistance to the soaking up of the moisture below the filling of the bill with a compact layer of the earthwork operation. These layers are called lifts up to 4 inches, 1.5 inch, 1 foot deep, depending upon the compaction necessary. Compaction equipment available. The material used in fill. The fill material must have the right amount of the moisture, referred to the optimum moisture content. Maximum compaction wet than the fill of the measurement before the compaction may be obtained with using the pneumatic tandem vibrator roller. Soil stabilization. There are three more soil stabilization. One is strength improvement that increases the strength of existing soil with enhancing the load-bearing capacity. Second purpose is dust control to alleviate dust generated by the operation of equipment after during the dry, warming, and arid climate. The third purpose is in soil waterproofing done to preserve the natural constructed strength of the soil and preventing the entire surface of water. There are two methods of applying soil stabilization. The first is a mix of a way that even necessary to combine two different soils together. With the stabilization is to be done with it in place of the mixing accomplished in blending with the soil with stabilization materials on job site. Off-site mixing accomplished by using station or mixing plants. Window mixing accomplished by mixing the material using a grater. Or the second way is surface penetration and application of the compost, placing the soil treatment material directly existing ground surface, spraying it other means of distribution. Some of the additives used in soil stabilization are cement, lime, bituminous products, and calcium chloride, cement treated bases that are most commonly used for the purpose of upgrading and poor quality soil with the soil cement, mixture of the pulverized soil, the measure of the Portland cement, and water compacted high density. There are three types of soil cement. The first type of the compacted soil cement contains a sufficient amount of cement hardened the soil and enough of the moisture of both compaction and hydration of the cement. The second type of the cement is modified with which for the unhardened semi-hardened mixture of the soil and cement. The only enough cement is used for the change the physical properties of the soil. The third is the plastic soil cement, the hardest mixture of the soil with the cement that contains the timing, place, and enough water to produce a consistency similar to that with the plastic mortar. Plastering mortar. These basic materials needed when working the soil cement or soil Portland cement and water. The soil can be also made into the combination of gravel, sand, and clear sand, salt, and clay. There are major control factors when working with the soil cement or as follows. The proper cement is needed as a rule of thumb is about 150-pound bag per square yard. Proper mixture content, one soil. Example, the firm cast should be made with squeezing in your hand without squeezing any water. Adequate compaction. The principle of compacting soil cement with the same for compacting same cement without cementing treatment with the soil cement mixture of the optimum mixture content should be compacted maximum density with finish immediately maximum moisture loss and variable duration compaction indicated with graying off the surface that should be replaced with light applications of water. Okay, occasionally during impaction, the treated area that may yield with the compaction equipment that is made to do with one more of the following causes of the soil cement mix with a much bigger wetter than the optimum moisture content. 2, the soil may be too wet, unstable. 3, the soil must be too heavy in the soil. If the soil cement mix is too damp, there should be aerated with the use of scarified with a grater. If the dry near optimum moisture content, then it's compacted. Technique in earthwork operation. Technically, the earthwork operation consists of the new known equipment needed for the operation: pioneer, clearing, grubbing, stripping, draining, grading, excavating. These operations are done primarily for the heavier construction, such as bulldozers, graders, hand-powered felling equipment exposed for the fires as you the many of the completion of these operations. All right. Caution: large-scale clearing, grubbing operation often produce damage and environmental effects such as increased soil erosion, reduction of atmospheric oxygen, destruction of wildlife habitat, introduction of particular material into stream riverbeds, causing increased situation of algae growth. Federal regulations may require environmental impact statement and assessing prior to the beginning of the clearing operation. To prevent these damaging effects, save as much vegetation as possible, such as trees, grass, and other plants to hold the soil in place. Construct shallow trench and application plastic barriers and hay bales around the perimeter. The project will help to contain the water runoff of the streams and rivers, preventing of the situation. Burning shrubs and stumps should be done with only an atmospheric condition favorable to the material burned and is dried. However, do not use petroleum-based fires to start fires, as fuels do not burn completely and seep into the underground water table. No burn permit is required in all burning areas of operation of construction forest projects to prevent wildfires and reduce smog. When determining the method of the earthwork operation, needed to consider the following factors. The acreage should be clear of the type of the density of the vegetation, the physical feature of the land, the expected weather condition, the time and the available completion of the job. The first result of the combination of the methods should be used in sequence operation, used the method most suitable and effective for the job. Equipment. Know your equipment limitation, the operational characters, spare part of the knowledge they need to know the efficient equipment operating earth movement jobs. Equipment production must be determined the correct amount with the type of the equipment selected for the job. Equipment production rates are available in CB Planner's Estimator Handbook, Navy Pack 30405. The handbook provides information estimated core construction work elements, material quantities, including equipment and manpower requirements. Before removing earth operations, it is necessary to remove the overgrowth, boulders, other obstructions. Also, you often build a drainage system so the construction site will drain. These operations are carried out with a bulldozer dozer, scrapers, graders, similar equipment. Loader, hauler, and scrapers usually referred to as either the heap or truck. When the moving earth is taking the full heap, a load make it heap and truck load. The heap and truck load. Cutting in either earth moving operation travel can be time consuming. Suppose you're operating with a 12-foot cap with a cubic yard scraper that carry area up to 15 cubic yard heap load. If you can only struck a level load with the 12 cubic load, you lose 3 cubic load each trip. The move with 60 cubic yards takes 5 trips. The only 12 cubic yards have the haul each time. The hauling full and heap loads, you will have moved the same amount of material on 4 trips. If you haul a short unit, wait until going into the cut. You can increase the production, taking only good load somewhere between the truck and the heap, the moving on rather than spending extra time obtaining the heap load. On most construction jobs, both cuts and fills are required. That your job and efficiently plan your job. The material taken out from the cut is filler area known as the balancing material. Pioneering. Pioneering refers to the first work over an area of the overgrown rough of the making with the area accessible for the equipment and either the project. The pioneering operation for the clearing, stripping, and grading of the drainage area that will done practically at the same time rather than perform a separate operation. The dozer starts along a predetermined route, leaves the road behind it. And this may be the whole road with which the trucks equipped will use the later operation. Suppose the dozer operation will get the job cutting in the job of such a mountain. You use the access proposed airstrip to reach the mountain. The stream developed into the water supply system, which would start and how would you proceed to route your machine mode on the road so the valve will take the survey parties used to start your road at the highest point possible and let the force gravity help your dozer. In clearing inside hill cuts, brush and trees should be the farthest enough of the side of the road so that they will not be covered in the earth. It's even better with a cast over the edge of the angled blade of the dozer where the road is cut. When cutting the road, do not watch the grade stake immediately ahead of you. You will find the finish yourself below the grade. Instead, watch 1/3 force stake down. Alright, clearing. Clearing is a construction operation consisting of cleaning of the designated area of the trees and shrubs and timber and brush and other vegetation, rubbish, removing the strip of the boulders, other material embedded in the ground, disposing all the material cleared. Clearing, grubbing, stripping the different type of every climatic zone because of every different type of the forest vegetation. The nature of the forest can be determined with direct core of the principal climatic factors, including precipitation, humidity, temperature, sunlight, direction, prevailing wind. The type of the forest can be generally classified as temperate, rain, monsoon, dry, and arid climate. Whether it's in they exist. Curly usually consists of pushing around up or out of trees and stumps and bush in both directions from the center of the area to be cleared, but the cleaning should be accomplished so that debris and spoiled matter is placed in the designated spot with only one handle. The clearing land handling strip, for example, is generally necessary to dispose of the material along with each side of the strips outside of the construction site. If the site permits the burning of the haul distance, it can be reduced in piling the brush and stumps and trees on the stump. The burning then production on this field must be estimated rather than calculated. Alright, grubbing. Grubbing consists of the uprooting and removing the roots and the stump of the grubbing stump that are difficult and impossible, even with the winches should be burned and blasted. Very supervisor will decide the method. The stumps can be removed. The blasting qualified blaster must be called upon to do the job if they are burned. You must be assigned to the task. Green stump that requires the continuous application of the heat before catch fire. Check with your supervisor for safety measure that you should keep the fire from them getting out of control. If you do have any stump burning, remember that it may take as long as 3 to 4 days for the stump to burn out. Keep a check on the burning depending on the period. If the project is high with the property priority time being must be saved, stumps will be probably blasted rather than burned. When stumps have been removed, they refill with the holes in level area to prevent the accumulation of water. Alright, stripping consists of removing and disposing of objectionable topsoil and sod, but they may either follow with the done with the clearing and the grubbing. The actual earth begin with the stripping of the surface of the soil. Rocks are removed. The area of the be excavated deeply. Embedded rocks, large boulders may have to be blasted before they can be removed. The material removed by stripping of the spoil, unless otherwise directed, you may dump the soil along the area to be excavated with the range of the earth moving equipment. If the spoil will not put in a use such as turfing and furnishing of the shoulder of the roadway should be wasted along the edge of the project shown in Figure 1564. Take care not to disturb the necessary drainage. Our equipment commonly used the stripping of the consists of the dozer scraper that used the grade and mentioned that earlier the most often used the removing trees. The dozers can handle short haul excavations up to 300 feet. For long haul excavation over 300 feet, scrapers should be used. The scraper being used on fine soil with stripping and greater issues mainly with the shaping of the finishing of the strip to surface and adaptable. Allows also the ditching and side casting for slope banks. Our drainage is a construction facility needed to allow the excessive water to absorb water to flow over the construction site. Properly designed, the constructed drainage system are one of the most important projects of the construction. Without Proper drain of the rainwater with water running off the surrounding ground that could turn the area into the lake. If necessary to drain the off of the surface area of the would be soaked down in water with the subgrade. Elements determine the drainage need of the road on project site with the amount of the rainfall in the area with the bounds for the area that can be used for collecting channel, excess of the surface of the subsurface of water in such as lakes and ponds and streams and voids or gullies. Type of the soil is critical in the design construction with the road of poor judgment is to construct the road over the trough, clay, sand, and other undesirable material. If it cannot be properly compacted, it is the best bypass type of the material. After the road surface is entirely endured continued use for the years, it has most firm support with this subgrade. All organic materials such as living and decayed vegetation should be removed from the area of the subgrade and left the roads for emergency as in temporary detour. Military road designated with the building road conserve the type of the drainage, the type of the soil, the amount of the clearing and the grubbing necessary to facilitate the drainage. Excavated diversion ditches that connect the surface of the water natural channels. Outfall ditches. Outfall ditches are constructed to drain low and boggy spots on all points at the end of the system. The accumulated runoff discharge of the disposal points runoff. The technically known as discharge. The discharge point in the system is also called the outfall. Prominently, work is done at the same time the area is cleared or grub. The finished drainage sometimes system usually consists of the ground slope ditch and culverts, gutters, storm drains, underwater water drains, open lake channels, open channels should. Figure 564 shows stripping stockpile waste area. Our bees need to interpret the controls over these should be dug with a bulldozer, scrape the bike over the motor graders, depending on the circumstances. Culverts should constrain with the drain water across the construction site. Subdrains or drained groundwater are usually excavated with the ditches back over the drain. Retrieve the French drains perforated open job joint tidal pipe. The figure 1565 show the typical covered French drains. Runoff water from the rain with the melted snow removed from the area of the construction. Adequate transverse job shall open the ground. Runoff is collected with the ditches. Drain the nearest natural drainage channel. Drainage construction site can be provided with the building end of the side sloping toward the middle of the sloping from one end to the other. In these type of the drainage constructions are shown. Our typical section of the covered French drains, the minimum 6-foot impermeable filler mill, open joint type, perforated pipe, minimum feet 5 foot, minimum 3 foot, 3 foot, minimum 12-foot diameter ground symbol, pavement and surface treatment, base course, filter material tile, perforated pipe, minimum of 6-inch impervious material ground symbol, cover drains, French drains, water intercepted before reaching grade and subgrade and roadway. It shows the longitudinal drainage roadways. Grading excavation, cutting with the high spot for the grade, filling with the low spot for the cutting down with the high spot to even enough the suitable fill of material made with the fill. This low spot, however, there may be the necessary to develop the other sort of the fill material site with the hard rocky terrain. Loosen breaks over the dozer's ripper before the material for the it can be placed in the low spot. The suitable foundation must be prepared. Material of low bearing capacity may have to be dug before the fill is placed. Base of course, the base course distribute the wheel load strength of the surface pavement with the subgrade sense of the strength of the base core of the concentrated, then the subgrade of the base core of the must be stronger. Placement and compaction when placing and spreading material for the course of the material of the base of the subgrade start with the noise point nearest this the source at the point farthest from the source, then place the material progressively away from the source. The source, the perspectively the advantage of working the point nearest the source that's hauling the equipment to be routed over the spread material, which helps compact the base core that avoids cutting up the subgrade advantage of the working point farthest for the source of that hauling equipment further than compact subgrades reveals any weak spot for the subgrade and interfere with the last of the movement and spreading of the compaction equipment. Or your base course compaction must be produced in uniform dense later confirmed everywhere with the specification requirement. The thickness of the lift should not be exceeded with that which may be compacted required density. The thickness of the lift is determined by the size of the compaction equipment using 6 inches for the rollers and 3 inches for less when using tampers. Note, optimum measure content must be maintained during compaction. Figure 16, paving operations and equipment.